Welcome. We're starting chapter 6 today. We're starting out with the exponential growth. And just remember, exponential equations are what we talked about last chapter. And that equation is y equals initial value times your multiplier. And then remember, your x is in the exponent. Okay, so that's what we're building off of here. And the question says you were rewarded a magnificent Mongolian multiplying moth for winning a multitude of Monopoly matches. You are told that your 2-inch wide moth will double in size every day. Complete the table and graph to show your moth's growth. So since it's doubling every day, x is the number of days, and y is going to be our width in inches. So at day 0, we are at 2 inches. And again, we are doubling, means the times 2. So day 1, 2, 3, 4, and 5, we're just going to multiply by 2. So 4, 8, 16, 32, and then 64. We're then going to graph it, and I'm going to say x is your number of days. So I'm labeling that on my x-axis, and I'm going to go by ones. And I'm going to say y is my width in inches. And I'm going to go by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So even though 64 is going to be slightly off, we'll be able to approximate where it's going to be. So 0, 2 is right about there. 1, 4 be just below that tick mark because there's 5. 2, 8, 3, 16, 4 is 32, and then 5 is 64. So 64 is going to be right about there. And then we have to decide if we're going to connect the points or not. Remember, to make sure it's continuous or discrete, you have to look at the x-axis. Since x is number of days, you can have part of a day, so therefore we should connect them. Days are broken up into minutes, hours, seconds, so we can have part of a day. We'll connect them. All right, so what is the equation that represents the size of this moth? So since we're multiplying by 2, again, we're using the exponential equation, initial value times your multiplier to the x. Our initial value is 2, because that's what's next to the 0. Our multiplier is 2, because that's what we're multiplying by, and that's to the x power. How big will it be in a week? Well, remember, x is number of days, so we have to figure out how many days there are in a week, which is 7. So we will be doing 2 times 2 to the 7th power. Just remember, you do need to know how to type those in to your calculator. So you should have that caret button. We look at this here. 2 times 2, and then remember that little button right there is what we're talking about, to the 7th. So 256. If we're figuring out now how big was the moth 2 days ago, so remember, as we went forward, that's how many days we've owned it. If we're talking about 2 days in the past, we're going to have to go back here. And if we go back 2 days, that means we're actually plugging in -2 in. So I'd be doing y equals 2 times 2 to the -2nd. When I type that in, 2 times 2, exponent here, -2nd, I get 0.5. So it's 0.5 inches. And this should also have inches with it. 0.5 inches. Was the moth ever 0 inches wide? No. And if you think about it, we are really dividing by 2 going backwards, and we can never get to 0 by dividing. So what we want to do is we want to go back then a little bit. We're going to add back into our graph what it would look like, and it would just get smaller and smaller, but it's never actually going to touch 0. So that's what we're trying for here. On the other side, we have exponential decay, so that means it's going to decrease. So we have some poor financial advice, and we invested in the sandpaper Snuggie. and our investment value is decreasing 50% each week, and today it's worth 500. We're going to complete the table and graph again. So now, since it's decreasing every week, X is number of weeks, Y is your amount of money. And so at week 0, currently it's 500. No weeks have gone by. 1 week, 2 weeks, 3 weeks, 4 and 5. So 50% is 1/2, so we're multiplying by 1/2, or 0.5. So half of 500 is 250. Half of 250 is 125. Half of 125 is 62.5. So $62.50. Divide that by 2, we get $31.25. And divide that by 2, and we get $15.63. And again, I rounded that to 2 decimal places because we're talking about money, and money is always 2 decimal places. As we look at the x-axis here, x-axis is number of weeks, and y is the amount of money. And here I'm going to go by 50s, or x's I'll go by 1s, but my y's I'm going to go by 50. So 50, 100, 150, 200, 250, 300, 350, 400, 450, 500. So we are at 0, 500. 1 is 250. 3 is 60. No, sorry, 2 is 125. 3 is 62.5. 4 is 30. 5 is 15. And again, we can have part of a week. So we're going to continue and make this continuous and connect the points. So then it's going to say, what is the equation that represents the value? So again, it has to be that initial value times your multiplier. Here, our initial value is 500. Our multiplier is 1/2, and it's to the x power. How much will your investment be worth in 10 weeks? So again, now we're plugging actually 10 in for x because x represents number of weeks. So I'm putting 10 in. Go to our calculator, 500 times 0.5 to the 10th. And again, we need it to be 2 decimal places, so we're talking about money. So that would be 0.49. So 49 cents. Man, that lost a lot of money. Not a good investment. What was your investment a month ago, which is 4 weeks? So again, this is going in the future. In the past, I'd have to go back. So I'd have to go back 4 weeks. So I'd be plugging in a -4 for the x. So I'd be doing y equals 500 times 1/2 to the -4th. 8,000 is what we got. $8,000. Woo! $8,000 down to 49 cents. Terrible investment. And then will our investment ever be worth $0? Well, technically no, because as we keep going down, we're multiplying by 1/2, and you can never get to 0 by multiplying by 1/2. Will it get less than a penny? Technically yes, but the graph will never really touch 0. So make sure you're kind of having that graph that way. And that's what we'll write here. No, multiplying by 1/2 cannot get us to 0. All right, and then the last thing we're going to look at is some notes here. So our general form of an exponential is y equals a times b to the x. So before we always said initial value times your multiplier to the x, same thing holds true. It's just now we're going to abbreviate it like this. So a is your initial value. So instead of writing initial value or IV every time, we're just going to write a. B is still your multiplier. So again, instead of writing an MULT or multiplier, we're writing a B. So the graph for an exponential is always a curve, and it has a horizontal asymptote. Now, what's a horizontal asymptote? What the heck? All right, horizontal asymptote. Here's our definition. So this first one's like the book definition. I don't really like it a whole lot. It doesn't move me at all. So the book definition is an imaginary line that tells you how a graph behaves as x gets larger or smaller. This is what I like. It's an imaginary line that the graph gets really close to but never touches. So if we looked on our previous page here, the sandpaper Snuggie graph, the graph got really, really, really close to the x-axis. We never actually touched it. So we have the horizontal asymptote right here. Same thing here. As we went back in time, the graph got really, really close to 0, but never touched it. So we have a horizontal asymptote on the x-axis here as well. So I like to call this the MC Hammer line. Why do you think we call MC Hammer line? Because we can't touch it. Can't touch this. All right, so I will call it the MC Hammer line often. Just know you can't touch it because it's an asymptote. All right, as we keep going on, increasing. I know that the exponential function is increasing when the graph starts low, close to our asymptote. Okay, so close to a y value 0, but never touching it because MC Hammer's here saying you can't touch this. And it's going to curve up. Or when the equation looks something like this, y equals 2 to the x increased. Or in general, when the b is greater than 1. So anytime that multiplier is greater than 1, it's going to increase. 2, 3, 5, 10. Multipliers would all increase. Multiplier 1.5 is greater than 1, still would increase. Multiplier 1.01, still greater than 1, it would increase. As we look to do our domain and range, remember, I'm going to set it up with my x and my y. For my domain, how far left does it go? Get my handy dandy note card out. It goes as far left as right here, but there's an arrow, so it's going to keep going left forever. So we'd be at negative infinity. How far right it goes, moving from left to right, it looks like it stops here, but again I have an arrow, so that means it would keep going to the right forever as well. So all real numbers are negative infinity to infinity. In regards to the range, how low does it get? So again, it looks like it stops about there, but we know that it's never going to get, it's getting really, really, really close to 0, but never actually touching it. So I'm going to put a 0 there, but I'm not putting the equal to because it will not equal 0. And then how far up does it go? Well, there's an arrow, so it's going to go up forever, so to infinity. As we look at the decreasing starts up high, curves down low, and then gets closer and closer to our MC or hammer line or asymptote, but never touching it. An equation that would decrease was our sandpaper Snuggie had the multiplier 1/2, so y equals 1/2 to the x. Or when your multiplier is between 0 and 1. So anytime your multiplier is between 0 and 1, it would decrease. So if multiplier of 0.9 would decrease, multiplier of 0.6, 0.5, 0.2, 0.01 would all decrease. For our domain, setup is similar. But again, we would be going to the left forever. So negative infinity, to the right forever, positive infinity. How far down are we going? Again, we're getting closer and closer to 0, but not touching it. So I put the 0 there, but I do not put the equal to because I'm not touching it. I just get really, really close to it. And then it goes up forever. All right, that is our first section.